Awesome. Hello, everyone. My name is Nick Weisenegger, and I'm here with Elon. Unfortunately, our teammate Jacob couldn't make it today, but we did a comparative analysis to see if ChatGPT 3 was better than Google Translate at translating on various languages.
All right, so the presentation overview, we're going to start with the problem and objective, then go into what ChatGPT is, our hypotheses, design of experiment, how the blue score is calculated, data analysis, and then we'll draw some conclusions.
So the problem that we basically wanted to see, at the time when we were doing our project, we just got kind of like used to starting to be able to use ChatGPT and its like ability to generate text. And one of our members thought, um, what if ChatGPT, since it is like trained on so much data, is it going to be better at translating? Because it is a generative model, and it has a lot of text that it's been fed, and to see if that would be better than Google Translate.
Yeah, so like Nick said, it's a natural language processing model. It uses deep learning to generate human-like responses to text-based conversations, so it should be able to have the capabilities of translating in different languages. And since it's been trained on such vast amounts of textual data, we thought it'd be a good competitor to Google Translate. And then we just wanted to learn and understand how those two can compare.
Awesome. So our hypotheses were that the mean of the blue scores, which we'll get to in a second, of ChatGPT, will be equal to the mean scores of Google Translate. That was our null. Our alternative was to see if ChatGPT's mean blue scores would be greater than Google Translate's.
So for design of experiment, we have our input variables, the English phrases. We're going to have 5 different languages, and we would input those into 2 different software, giving us 10 different levels to do analysis on. Um, these phrases ranged in complexity. So the original English phrase could have been something simple sentence, up to something more complicated. And that would produce a response variable, which is our blue score given by Python code.
So one thing to note about the languages we chose 5 languages. They kind of range in complexity and how often they're spoken in the world. Some are Latin based, some are not Latin based. So that is just something to note about the languages we chose. But getting to the blue scores, it's basically means the bilingual evaluation understudy. So basically, it gives you a score on 0 to 1 to see if you are doing a great translation or not. So we basically, as you can see in the example below, we start a phrase in English, and then we translate it to Russian, and then we take the Russian phrase and then we spit it or you put it back in the software, the translation software, to give us a English phrase. And basically, the blue score is just going to see the first English phrase to the last English phrase and give you a score of 0 to 1.
So to get more detailed on the procedure, for Google Translate, we had 6,780 random phrases. We were able to do a lot more phrases with Google Translate, given the nature of the program. You can just upload a large file to it and it'll output a long list of translations. So that was then translated to each language, reverted back to English through the same program, and then run through our Python code, and that would spit out blue scores. For ChatGPT 3, there's a limitation on the number of characters that can be inputted. So these had to be done manually, which reduced our number of samples. But the same process goes there. Translate it to a language, revert back to English, and then run it through our code.
Also, one thing to note about the ChatGPT phrases is that we did use a different computer because ChatGPT can look at itself like in the past with your past like prompts. So if we translate like let's say 10 phrases on the same computer from one language to another language and then back, it could potentially use itself and realize, oh, this is just the same thing I just was asked. So it could spit out the same phrase potentially. So we used different computers. And starting with the data analysis, these are some blue score charts that we were given. And as you can see on the right, Spanish and Swedish generally scored higher than the ChatGPT. And they can kind of be said generally that the ChatGPT blue scores were lower just in general. Next slide. So as you can see, the problem with our data though is that it isn't normal. So that is a drawback. Due to the nature of the blue scores, the scores of 0 and 1 were very prominent. So that's why you see in the histogram the two tail ends are very they have a lot of values towards the 0 and the 1 on the edges, which is a drawback. But Google Translate did end up being statistically significant and higher than ChatGPT by about 0.1. And getting into the ANOVA tests that we ran, so the software and language interaction was not important. The p-value was much greater or a little bit greater than 0.05, which basically means we can confirm that there is no real interaction. And as you can see in the bottom, there was statistical significance between the languages as well. If you were to use any language like Swedish or Spanish, you generally would score higher um, for either software than German, Swahili, and Russian.
So yeah, in conclusion, there's no interaction between language and software. Google Translate was a better translation software for chosen languages. The Spanish and Swedish translations scored highest. German was in the middle, and then Swahili and Russian scored lower. In hindsight, we could use more languages, more complicated languages of Latin base or not of Latin base. And we are limited by ChatGPT 3 because there is a ChatGPT 4 at the moment. So we were able to use ChatGPT 3 at the moment or at the time. So that could be explored in another experiment as well.
Awesome.
Yeah.
Thank you so much.